Hey guys, welcome back. It's Rishi once again, and in today's video, we're going to be continuing our journey through Python classes. And what we're going to be starting off with is inheritance. And we're going to learn how inheritance can simplify the creation of classes that are related to each other. And we're also going to learn how to use instances of one class's attributes in another class to keep each class simple. We're going to dive deeper into classes and see how we can store classes in modules and import classes that you need into the files where they will be used, just to ensure that your projects are always organized. Before finally learning how to style your classes using Python's conventions. I'm so excited about our second part of our classes video, so let's dive into this right away. So, what is inheritance? Now, you don't always have to start from scratch when writing a class, just as we've seen in our previous video. If the class you're working with is a specialized version of another class that you've written, then you can use inheritance. And when one class inherits from another, it automatically takes on all of the attributes and methods of the first class. The original class is called the parent class, and the new class is the child class. And many of you must have heard the difference between a parent class and a child class. So the child class is simply inheriting every attribute and method from its parent class, but is also free to define new attributes and methods of its own. And this is where I'm going to be diving through the init method for a child class. Now, the first task Python has when creating an instance from a child class is to assign values to all of the attributes in the parent class. So to do this, we're going to use the init method. So as an example, let's model an electric car. An electric car is just a specific kind of car, so we can base our new electric car class on the car class that we wrote earlier. Then we'll only have to write code for the attributes and behavior specific to the electric cars. So let's start by making a simple version of the electric car class, which does everything the car class does that we wrote in the previous video. And for those that haven't watched our previous video, please go ahead and click the link below where you will see a link to our previous part 1 classes video. However, those who have watched part 1, let's go ahead and dive into this now. So you can follow this tutorial, or you can go ahead and watch this side by side with the code that you already have from the previous video, which will make things a little bit easier. So I'm going to go ahead and comment out all of my code, and I'm going to paste out my car class before continuing. So I've now got my car class that we had written in our previous video. Let's go ahead and create a new class, which is based on our electric car. So let's go for class electric car. And again, this is where I'm going to be using my camel case. And remember, because it is a class, we use our capital letters. And then we go ahead and write out our doc string before going ahead and writing out our method, where we will write out our init method, and we'll take self as our first parameter, and then the make, the model, and the year. This is where we will be initializing our attributes of our parent class. And again, I'm going to be writing out super to call the parent class. So let's take a look at what I've done first. So I've started ahead with my car class, and when we create a child class, the parent class must be part of the current file and must appear before the child class in the file. So as you can see now, we've defined our child class, which is electric car. So the name of the parent class must be included in the parentheses in the definition of our child class. And so the init method then takes the information required to make the car instance. Before moving over to line 135, where the super function is a special function that helps Python make connections between the parent and child class. So this line is specifically telling Python to call the init method from electric car's parent class, which gives an electric car instance all of the attributes of its parent class. And the name super comes from a convention of calling the parent class as a superclass and the child class as a subclass. And we test whether inheritance is working properly by then going ahead and trying to create an electric car with the same kind of information that we'd provide when making a regular car. So let's go ahead and make an instance of this, and I'm going to go for my_Tesla. I'm going to equal this to my electric car class, and then I'm going to put in some arguments. And let's go for Tesla, let's go for Model S, and let's go for 2022. And then I'm going to go ahead and print this out. So I'll call my Tesla using my dot notation and my get descriptive name with my empty parentheses. Wonderful. So now I've made my instance of the electric car class and I've stored it in my Tesla. So now this line calls the init method defined in an electric car, which in turn tells Python to call the init method that is defined in our parent class car. And we provide the arguments Tesla, Model S, and 2022. And so aside from the init class, there are no attributes or methods yet that are particular to an electric car. And at this point, we're just making sure that the electric car has the appropriate car behaviors. So let's now go ahead and run this. And so what do we see? 2022 Tesla Model S. And so the electric car instance works just like an instance of car. So now we can begin defining attributes and methods. Specific to electric cars. So let's take this one step further. Let's think about how we can define attributes and methods for our child class. So once you have a child class that inherits from a parent class, you can add any new attributes and methods necessary to differentiate the child class from the parent class. So let's add an attribute that's specific to electric cars, such as a battery, and a method to report on this attribute. And we'll store the battery size and write a method that prints the description of the battery. So just below my super function, let's go ahead and write self.battery size, and let's equal this to 70. And for those who remember in our previous video, when we're giving a value to an attribute, we don't need to assign this as part of our parameters. And then we'll go ahead and create a new method, and we'll call it define describe_battery. I'm going to call my self method here. And let's go ahead and put in a doc string, just explaining what we're doing here. And then let's go ahead and print this out before going ahead and calling my Tesla.describeBattery. So now we've gone ahead and written that out. Let's go ahead and explain this. So firstly, I've gone ahead and added a new attribute, which is self.battery size, and set its initial value to 70. And this attribute will be associated with all of the instances created from the electric car class, but won't be associated with any instances of car. And then we go ahead and add a method called describeBattery that simply prints out information about the battery. And then we finally call this method and we get a description that is clearly specific to an electric car. So let's go ahead and run this right away. And there we are. You can now see this car has a 70 kilowatt battery. And there's no limit to how much you can specialize the electric car class. You can add as many attributes and methods as you need to in order to model the electric car to whatever degree of accuracy that you need. Remember, an attribute or method that could belong to any car, rather than that's one specific to an electric car, should be added to the car class instead of the electric car class. And then anyone who uses the car class will have that functionality available as well. And the electric car class will only contain code for the information and behavior specific to electric cars. So I hope you can see how we can define the attributes and methods for those specific instances. But now you can also override any method from the parent class that simply doesn't fit with what you're trying to model with that child class. So to do this, we need to define a method in the child class with the same name as the method that you want to override in the parent class. So this now brings us to overriding methods from the parent class. So say the class car had a method called fill gas tank, and this method is meaningless for all electric vehicles. So you may want to override this method. So let's take a look at a way as to how we could do this. So if I go ahead and write out a method, define fill underscore gas underscore tank, and I go ahead and write out my doc string before going ahead and printing a message out. So let me go ahead and put this in the right area. So I'm going to go ahead and paste this just beneath my describe battery. And so now if someone tries to call fill gas tank with an electric car, Python will ignore the method fill gas tank in car and run this code instead. So when you're using inheritance, you can make your child class retain what you need and override anything that you don't need from that parent's class. Now, when modeling something from the real world in code, you may find that you're adding more and more detail to a class. And you'll find that you have a growing list of attributes and methods, and that your files are becoming lengthy. And in these situations, you might recognize that part of one class can be written as a separate class. And you can simply break your large class into smaller classes that would work. So let's take a look at instances as attributes. So let's take an example here. If we continue adding detail to the electric car class, we might notice that we're adding many attributes and methods specific to that car's battery. And when we see this happening, we can stop and move those attributes and methods to a separate class, which is called battery. Then we can use a battery instance as an attribute in the electric car class. So let's take a look at how we can simply do this. So I'm going to go ahead and create a new class as I did for my electric car class. But this time I'm going to call this class battery. Let's add my doc string. And remember now we've defined a new class called battery that doesn't inherit from any class. Then let's go ahead and write out our method. And let's go for battery size. And let's equal that to 70. Let's write out our doc string. And then let's go ahead and add our prefix self.battery size and set this to our variable battery size. So now our init method has one parameter, which is battery size, in addition to self. And this is an optional parameter that sets the battery's size to 70 if no value is provided. And then again, I'm going to take this child class here and paste it just above of my electric car class. And then I'll go ahead and copy the same describe battery class here and paste it just below my new method that I've just created. And please remember that the method describe battery has now been moved to this class as well. And now in the electric car class, we now can add an attribute called self.battery. And this line tells Python to create a new instance of battery with a default size of 70 because we're not specifying a value, and then simply store that instance in the attribute self.battery. And let's not forget to simply call self.battery and assign this to the child class battery before finally going ahead and calling this. So my.tesla battery.describe battery. And so now this will happen every time the init method is called, and any electric car instance will now have a battery instance created automatically. And we create an electric car and store it in the variable myTesla. So when we want to describe the battery, we need to work through the car batteries attribute. And remember, this line here simply tells Python to look at the instance myTesla, find its battery attribute, and then call the method describe battery that's associated with the battery instance stored in the attribute. So now hopefully our output is identical to what we saw previously. So let's go ahead and print this out. And what do we notice here? We've now got an error, and it says attribute error, electric car object has no attribute. So we go over to line 151. Let's go ahead and comment this out, as this line is referring to our self.battery, which we had written out earlier, where we equaled this to 70. But we don't currently need it at the moment, so we can comment this out as well. And let's go ahead and run our program. And there we are. We can now see we've got 2022 Tesla Model S, and the car has a 70 kilowatt battery. So this looks like a lot of extra work, but now we can describe the battery in as much detail as we want without cluttering the electric car class. So let's add another method to battery that reports the range of the car based on the battery size. So again, this is going to be done within our battery class, and we're going to go ahead and define another method. So let's call this getRange, which will take one parameter self, followed by our docstring. And now the new method getRange is performing simple analysis. So let's say if the battery's capacity is 70 kilowatts, then getRange sets the range to 240 miles. However, if the capacity is 85 kilowatts per hour, then it will set the range to 270 miles. So let's go ahead and get that done. Let's go for if self.battery size is equal to 70, then the range must equal to 240. If self.battery size equals to 85, then the range will equal to 270. And simply the output will now tell us the range of the car based on its battery size. So let's go ahead and write out a message, and let's equal this to this car can go approximately, followed by the range. Let's go ahead and add a multi-line comment before printing our message. Wonderful. And then let's finally scroll down to the bottom after our electric class, where we will simply call mytesla.battery.getRange. So let's go ahead and print this out. And there we are. This car can go approximately 240 miles on a full charge. So I hope you can see how we can model real world objects. And as we begin to model these, they become more complicated. And you'll wrestle with interesting questions such as, is the range of an electric car a property of the battery or of the car? And if we're only describing one car, it's probably fine to maintain the association of the method getRange with the battery class. But if we're describing a manufacturer's entire line of cars, we probably want to move getRange to the electric car class. And that getRange method would still check the battery size before determining the range, but it would report a range specific to the kind of car that it's associated with. So this brings you to an interesting point in your growth as a programmer. When you're battling with these questions, you're thinking at a higher logical level rather than a syntax-focused level. And you're thinking not about Python, but about how to represent the real world in code. And when you reach this point, you'll realize there are often no right or wrong approaches to modeling real-world situations. Some approaches are more efficient than others, but it takes practice to find the most efficient representations. So if your code is working as you want it to, you're doing well. But don't be discouraged if you're ripping apart your classes and rewriting them several times using different approaches. That's exactly what I've done. And in this quest to write accurate, efficient code, everyone has to go through this process. So I hope it was clear as to how we can simply create a parent class and then a child class, as we did with class battery, which we did with our electric car class, where we referenced our parent class car. Wonderful. So now this brings us to a point where we're going to be giving you 4 programs to cover. So feel free to pause here, where you can then go through these 4 programs, practicing how to code using everything that we've learned in our first section. And then press play when you're ready to go through the solutions. Welcome back. I hope those 4 programs gave you an insight into how you can write classes and attributes alongside your instances. So let's dive into our Chapter 8 solutions and let's go through our first program. So ice cream stand. And this is a specific kind of restaurant where we need to write a class called ice cream stand that inherits from the restaurant class that we wrote in exercise 8.1 or 8.4. So let's go ahead and get started. So I'm going to paste out my restaurant class that we created earlier, and let's go ahead and write out our ice cream stand class. So let's go for class ice cream stand, and we're going to call our restaurant class. And this is simply going to represent an ice cream stand. And let's go ahead and write out our init method, where we have our name, our cuisine type, and we're going to make this equal to ice cream. And then we have our super function here with our init method, and we're going to simply call our name and cuisine type before simply going for self.flavors and assigning this to an empty list. So now that we've gone ahead and done that, let's go ahead and create an instance of our ice cream. So let's go for define show underscore flavors, and let's call our self class. And this is where we're going to display all of our flavors. And then we'll print out a message with a new line, and let's go for we have the following flavors available. And then let's put in our for loop. And that's going to simply be for each flavor in self.flavors. Let's print, and using our format method, let's go for our placeholder, and let's go for flavor.title before finally calling our ice cream stand. Let's go and set a variable to big one, and let's go for ice cream stand. And that will be our name of our ice cream, followed with our flavors. Let's go for big one dot flavors, and let's equal this to a list of flavors. So let's go for vanilla, let's go for chocolate, and let's go for black cherry. And then let's finish off here with calling our describe restaurant and show flavors. Again, we've got our dot notation. Let's go ahead and put this just above our show flavors, and we can now see that's all been referenced and initialized. And let's go ahead and print this out. And there we are. We've got the big one serves wonderful ice cream, and we have the following flavors available. Beautiful. So you can now see we've referenced this from our restaurant class, and this is now inheriting it. And then we've gone for an attribute called flavors, which we have written out here. And that just stores a list of ice cream flavors, and then finally written out a method that displays these flavors whilst creating an instance of ice cream stand to call that method. I hope that was now clear. Let's go ahead and move over to our second program, admin. So in this program, we have an administrator who's a special kind of user. And we are going to write a class called admin that inherits from the user class that we wrote in our previous exercise, 8.3 or even 8.5. So let's go ahead and paste out that program, and then we'll go ahead and create our class admin. So I'm going to go ahead and paste that out here. And this is, again, if you remember, our user class with our first name, last name, username, and email. So now let's go ahead and create a new child class, and we're going to call this admin, and we're going to reference this with user within our parentheses. Let's put in our doc string. And then we need to go ahead and add an attribute, privileges, that stores a list of strings like can add post, can delete post, and can ban user, and so on. And so let's write out our method here. And we can now see that's referenced it from our user class. And then we need to finally go ahead and write out our self.privileges and assign this to an empty list before going ahead and writing another method, show privileges, with one parameter, which is self. And then again, we'll go ahead and display the privileges that the administrator has. Don't forget as well to add in your doc string at the above method here, which just initializes the admin. So now that we've gone ahead and written that out, let's go ahead and add in a print statement. We'll go ahead and go for new line and write privileges. For privilege in self.privileges, and let's print out our privilege. So now we've done that. This method will now show all of our privileges that lists the administrator's set of privileges, and then we'll go ahead and create an instance of admin and call our method. So we're going to simply go ahead and declare a new variable like I did in our previous program, and let's call Rishi the admin. Let's set his first name. It's going to be Rishi. Let's set his surname, followed by his email address, a username, followed by a location. And then we'll call our describe user. And then we'll write out our privileges. And let's go for can reset passwords, can moderate discussions, and let's go for a final one, which can suspend accounts. and then finally going ahead and showing our privileges. So rishi.show privileges, calling our final method, and let's go ahead and output this. And what do we see? We can see our user over here, and we can see our privileges, which is written out. And that's how you can go ahead and work on your user task that we had done previously and add on a child class which inherits all of the methods and attributes. Amazing. Let's now go ahead and move over to our third program here, which again is privileges. And we need to write a separate privilege class. And it should only take one attribute, privileges, that stores a list of strings as described in our previous exercise. So let's go ahead and think about how we're going to do this. Well, let's start off with a class privileges, and let's define our init method here. So we've got our class, we have our init method, and we're now going to move the show privileges method to this class. So let's go ahead and copy out our show privileges and paste it below here, before finally making a privileges instance as an attribute in the admin class. And by doing that, we're going to simply go ahead and create a new instance of admin and use the method to show its privileges. So let's add in our else statement, and that's simply writing out that if we have the privileges, then show them. Otherwise, print out a statement that says this user has no privileges. So let's go ahead and press enter and paste out our else statement that this user has no privileges, before finally going ahead and calling out our admin here. And let's finally create a new instance of admin and then again use these methods to show its privileges. So now that I've done that, I'm going to go ahead and call rishi.privileges and show_privileges. And now that I've gone ahead and done that, let's go ahead and call rishi.privileges once more, and let's equal this to rishi_privileges. So finally calling rishi.privileges.show_privileges. So now we've written that out, we can see that it's not being defined, and that's mainly because we've got our class just beneath this section here. So I'm going to go ahead and comment out this entire program here, just so it doesn't give us any errors. And then going ahead and pasting out our above user class. And that should now eradicate our error. And there we are. We've now got our instances and we've called them using our dot notation. Marvelous. So let's go ahead and run this and see what our output is. This user has no privileges. And then we've now got our adding privileges alongside the list of privileges that are being added here. Amazing. Okay, let's go ahead and move over to our final program. And this is battery upgrade. So now we need to use our final version of electric car from this section. And we need to add the battery class called upgrade battery. And this method should check the battery size and set the capacity to 100 if it isn't already. We'll then make an electric car with the default battery size and call getRange once, and then call getRange a second time after upgrading the battery. And that way we should see an increase in the car's range. So I'm going to go ahead and paste out our car class and our battery class that we had written in our previous file before we set out to complete these challenges. So that's all over here. We've got our car class as well as our battery class. So now let's go ahead and write out our method. And that's going to be upgrade battery with one parameter, which is going to be self. Let's go ahead and write out our docstring followed with an if and else statement. And that will simply be if the battery size is 75, then call it 100. So we're upgrading the battery to 100 kilowatts. Otherwise, print that the battery is already upgraded. And then we'll go ahead and we'll paste out our electric car class before simply going ahead and calling the instance. So we've now got our electric car class there. And let's now go ahead and call this. So let's go for a simple print statement and say make an electric car and check the range. We'll then call my underscore Tesla, and we'll assign this to our electric car class, and we'll add in our arguments. So we go for Tesla, we go for Model S as we did last time, and we'll go for 2022. We'll then go ahead and call my Tesla once again and use our dot notation to call battery and get our range before simply going ahead and printing out on a new line. Upgrade the battery and check the range again before simply calling my Tesla and battery with our upgrade battery. And then my Tesla with our battery and our range. So let's go ahead and print this out. And there we are. We now can see we've got make an electric car and check the range. And this car can go approximately 260 miles on a full charge. And then upgrade the battery and check the range once again, where it's upgraded to 100 kilowatts per hour. And then finally, the car can go approximately 315 miles on a full charge. Amazing. So this brings us to the end of our first section. And let's dive back into our classes file. You've done amazingly well, so keep it up. So let's move into importing classes. Now, as you add more functionality to your classes, your files can get long, even when you use inheritance properly. So in keeping with the overall philosophy of Python, you want to keep your files uncluttered as possible. And to help, Python lets you store classes in modules and then import the classes that you need into your main program. And if you would like an introduction into modules and imports, then please watch our previous video, which was Python 8, where we go through modules and imports in more detail. But again, let's go ahead and create a module which contains just our car class. And this may bring up a subtle naming issue if you already have a file named car.py in this chapter. But this module should be named car.py because it contains code representing a car. So remember the first rule of being descriptive. And we'll resolve this naming issue by storing the car class in a module named car.py. So if you do have another class called car.py, why not change it to my_car.py? Let's go ahead and create a new file and call this car.py. Marvelous. So let's go back into our classes file and let's take the class car. And we'll paste it in our car.py. And so now I'm going to go ahead and include a module level docstring that briefly describes the contents of this module. And remember, you should always write a docstring for each module that you create. So I'm going to go at the top of this class here, and let's go ahead and write down a class that can be used to represent a car. And now we can go ahead and make a separate file called my_car.py. So let's go ahead and right click here and let's go for my_car.py. And this file is simply going to import the car class and then create an instance from that class. And this is where we're going to write out from car import car with our capital letter. And we'll now call my_new car and equal this to our car class with some attributes. And let's go for Mercedes. Let's go for G class and 2022 before printing out my new car with our dot notation and get descriptive name. And then let's go with my new car dot odometer reading and let's equal this to 23 and then my new car dot read odometer. So again, remember this import statement here is telling Python to open the car module and import the class car. And now we can use the car class as if it were defined in this file. And the output will be the same as we saw earlier. So let's go ahead and clear our terminal and run this. And you can now see we're getting 2022 Mercedes G-Class and the car has 23 miles on it. So remember, importing classes is an effective way to program. Picture how long this program file would be if the entire car class were included. And when you instead move the class to a module and import that module, you still get all of the same functionality, but you keep your main program file clean and easy to read. And you also store most of the logic in separate files. So once your classes work as you want them to, you can leave those files alone and focus on that higher level logic of your main program. So now what if we need to store multiple classes in a module? So we can go ahead and do that, although each class in a module should be related somehow. So the classes battery and electric car both help represent cars. So let's go ahead and add them to the module car.py. So let's go to our classes.py and let's get our battery class and electric car class. And let's paste this in our car.py below here. So we've got our class battery and we've got our class electric car. And now we can make a new file called my_electric_car.py. And that's going to import the electric car class. So let's go so now we can go from car import electric car. And we'll call my_Tesla. And we'll simply equal this to our electric car with our arguments. And again, I can go ahead and simply add this on from my classes file here, which was simply this information. So let's go ahead and get this up and let's simply just paste this here. And this is the same output as we saw earlier, even though most of the logic is hidden away in a module. And let's just comment out my describe battery and let's print this now. And remember, this has the same output that we saw earlier, even though most of the logic is hidden away in a module. And we can now see we've got 2022 Tesla Model S with the car having a 70 kilowatt battery and the range. So that was an example as to how we can store multiple classes in a module. But let's see how we can simply import multiple classes from a module. So now the main key point is that you can import as many classes as you need into a program file. And if we want to make a regular car and an electric car in the same file, we need to import both classes, both car and electric car. So let's go ahead and create another file, and this is going to be mycars.py. And within this, we're going to simply go from car import car, electric car. And let's add on a new variable. Let's go for my BMW. And I'm going to equal this to car, as I'm calling my car class. And let's go for BMW. Let's go for X7. And then let's go for our year, which is 2022. And then let's go to print this out. So let's call our myBMW.getDescriptiveName. And then we'll call our Tesla. And let's call our electric car class, followed by our arguments, Model S. And then let's go for our 2022 again, before printing out myTesla.getDescriptiveName. And so you import multiple classes from a module by separating each class with a comma, as you can see here. And once you've imported the necessary classes, you're free to make as many instances of each class as you need. So in this example, we make a regular BMW X7 and an electric Tesla Model S. And there we are. We can see more than one instance being printed, both our BMW X7 and our Tesla Model S. But let's go a little bit further. Now we can also import an entire module and then access the classes that you need using that dot notation. And the approach is simple and results in code that is easy to read. And that is because every call that creates an instance of that class includes the module name. So you won't have naming conflicts with any names used in the current file. So in order to do this, all we would simply need to do is go ahead and write import car. And what this does is, this allows us to import the entire car module. We then access the classes that we need to from the module name.className syntax. And then again, we can go ahead and create the BMW X7 and create the Tesla Model S. And as well as importing an entire module, we can also go ahead and import all of the classes from a module. And that again would be from your module name, import everything, as you had seen in our Chapter 8 functions video. And this method is not recommended for two reasons. First, it's helpful to be able to read the import statement at the top of the file and get a clear sense of which classes a program uses. However, with this approach, it's unclear which classes you're using from that module because it's importing everything, hence the asterisk. And if you've seen our previous video, I also mentioned that this approach can also lead to confusion with names in the file. Let's say you accidentally import a class with the same name as something else in the program file. you can create errors that way that are hard to diagnose. And I show this here because even though it's not recommended, you're likely to see it in other people's code. So I want to expose you to the entirety of it. And if you need to import many classes from a module, you're better off importing the entire module and using that module underscore name dot class name syntax. And then if we move on to importing a module into another module, let's see exactly what happens there. So sometimes you'll want to spread out your classes over several modules to keep any one file from growing too large and avoid storing unrelated classes in the same module. And when you store your classes in these several modules, you may find that a class in one module depends on a class in several modules. And you may find that a class in one module depends on a class in another module. So when this happens, you can import the required class into the first module. So let me go through an example here. So let's store the car class in one module and the electric car and battery classes in a separate module. And we'll make a new module called electric underscore car.py. So let's go ahead and write our doc string in place. And let's go for a set of classes that can be used to represent electric cars. I'm going to go ahead and get my battery class as well as my electric car class from my car here. So let's paste this out in my electric car. Here we are. Beautiful. So now the class electric car needs access to its parent class car. So we import car directly into this module. So let's go ahead and write out from car import car. And you can now see if I scroll down that the errors have now disappeared. And we also need to update the car module so it contains only the car class. So let's go ahead and get our car class and paste it here as well. So now we can import each module separately and create whatever kind of information we need. And that again would be from our mycars.py. So again, if we jump into mycars.py, we can go ahead and run this file and still get our output. And there we are. You can see that's now being called. And so now we've imported our car from its module and electric car from its module. And we can then create one regular car and one electric car. And both kinds of cars are created correctly. So as you can see, Python gives you many options for how to structure code in a large project. So it's important to know all these possibilities so you can determine the best ways to organize your projects as well as understand other people's projects. So try doing everything in one file and moving your classes to separate modules once everything is working. And if you like how modules and files interact, try storing your classes in modules when you start a project. And mostly find an approach that lets you write code that works and then go from there. Brilliant. So this now brings us to the end of our second section where I've given you 3 programs for you to write. Go ahead and write these out and press play when you're ready to go through the solutions. Welcome back. Let's now dive into our Chapter 8 solutions where we'll be going through our 3 programs. I hope you had enough time to practice and go through all of the different modules and classes that we've created. So let's go ahead and see what imported restaurant is all about. So now using our latest restaurant class, we need to now go ahead and store this in a module and make a separate file that imports restaurant and then make a restaurant instance and call one of the restaurant methods to show that the import statement is working properly. So for this program, I'm going to go ahead and create a restaurant.py file here. And this is where I'm going to paste out my restaurant class. I'm then going to go ahead and create another file and call this my_restaurant.py. And this is where I'm simply going to add in my from restaurant import restaurant. So this is going to be my module. So this is where I've got my channel club. I've called my class restaurant and I've got my arguments, which is the name and the cuisine type. I've then gone ahead and called my methods describe restaurant and open restaurant using our dot notation. So let's go ahead and run this program. And there we are. We can now see we've got the channel club serves wonderful steak and seafood, and the channel club is open. Come on in. So again, I hope you can see how we've gone ahead and pasted out our restaurant class. We've then gone ahead and called it from restaurant, import our restaurant class. We've got our arguments in place, and then we've called it using our dot notation. Wonderful. So let's go ahead and write a little message here. Beautiful. Let's now dive into the next one, which is imported admin. So this is where we need to start with our work from our previous class, and we need to store the classes user, privileges, and admin in one module. And then go ahead and create a separate file, make an admin instance, and call show privileges to show that everything is working correctly. So once again, I'm going to go ahead and create a user.py class, where I'm going to be writing out my user class, as well as my privileges and admin class. And then I'm going to go ahead and create a separate file and make an admin instance and call show privileges to show that everything is working. So let's go ahead and create my user.py. So now that we've created our my user.py, let's write out our import statement. So from user import admin. I'm going to go ahead and copy out our user code that we had written out previously, which takes all of our relevant information, and let's paste it out in this file here. Let's uncomment this, and we can now see we've got the admin, we've got our privileges. So let's go ahead and write out our instances. So let's now go ahead and call these privileges. So let's go for rishi.privileges, and let's equal this to rishi_privileges here. And let's put in a print statement this time. Let's go for the admin with our place value holder, rishi.username has 3 privileges. And let's remove this adding privileges line here. And then let's call rishi.privileges here, and let's show these privileges. Marvelous. So let's now go ahead and print this out, and let's see what we get. Amazing. So we can see all of the information about our user, the privileges that this user has, and then the admin has 3 privileges, followed by the 3 we have listed out. And that again was copied out from our 8.8 program that we had written, all the way down for our 8.11 where we imported the admin. Marvelous. So I hope you can see how we can apply the previously used and written programs for the programs now. And then finally, 8.12. This is where we have multiple modules. So we need to now store the user class in one module and store the privileges and admin classes in a separate module. And now in a separate file, create an admin instance and call show privileges to show that everything is still working correctly. So let's now dive into our user.py. And as you can see, this was our class user. And let's go ahead and firstly add on our docstring, which was a class for modeling users. So we've got our class user now, and let's go ahead and create a new file called admin.py. And within this, we are going to be setting a collection of classes for modeling the admin account. And this is where we're going to import our user from our user. And I'm going to go ahead and paste out my admin class as well as my privileges class before going ahead and creating a new file, and that's going to be my_admin.py. And this is again another module that I'm creating. So from my admin, import admin. And again, remember, admin with a capital A is your class. And I'll go again and paste out all of my information about my admin, such as his privileges, as well as the print statement. And then now we can go ahead and print this out, and you'll see we get the same output. And there we are. We have our user information, the privileges, and then the admin and their privileges. So I hope that was now clear as to how we can work with multiple modules, storing both the user class in one module and store the privileges and admin classes in a separate module. So that actually brings us to the end of our program and the end of our video. I hope this video was really useful and it's taught you many things about imports, classes, instances, and how we can work with different imports. And you learned that inheritance can simplify the creation of classes that are related to each other. So let's go back to our classes and let's summarize everything that we've completed. So inheritance was our main topic that we went through. And you learned that inheritance can simplify the creation of classes that are related to each other. And you learned how to use instances of one class as attributes in other classes to keep each class simple. You saw how storing classes in modules and importing classes you need into the files where they'll be used can keep your projects organized. So your learning doesn't stop here. Go through these challenges once more in order to understand exactly how Python's libraries are working. So now in the next chapter, in chapter 10, you'll learn to work with files so you can save the work you've done in a program and the work that you've allowed users to do. And you'll also learn about exceptions, a special Python class designed to help you respond to errors where they arise. So don't forget to like and subscribe our video. If you have any comments or any feedback, feel free to message us right away. I hope you have a great day and don't stop learning Python. Thank you.